Hey guys, we're Group C, and this is our AEV video.
Okay, cool. We good?
If your battery runs out, you pick one up.
It's a good change. It's a good change. Nice thing is
Sensors repaired.
Hey, ride home with us. And they were like, what's it got?
Hi, I'm Stefan. My role in the team is pretty much a utility player. If this was baseball, I just help a little with everything. So one cool thing about this project is that the work we did earlier in the semester, it plays a big role into what we do when we get more focused on the AEV later in the semester. One of these things is the orthographic drawings, which is basically drawing a shape or an object from 3 different views. You have the top view, front view, and the right view, and then you got the isometric view of the actual object. And we use this style of drawing to come up with our AEV design, or our possible AEV designs, and then we use the testing to decide on one. But we did a lot of practice with that earlier in the semester, and it became very useful.
Okay, cool. We good? Oh, there's a wire cutter.
Keep the LED
Hi, my name is Blaine Klein. I'm an agricultural engineer, first year from Group C. I do the SolidWorks representations of our AEV model. On the screen now, we have the SolidWorks design that we chose to use. It's kind of like using a digital erector set. You just point and click and tell each piece where you need to go. Each piece on here is its own individual piece that was provided to us by the engineering department at Ohio State. On screen now, we have the exploded view of the assembly model that we chose. It's kind of like a sandwich. If you take every piece of the sandwich apart and pull it apart, you can see what's all in the sandwich. So what we have here is the base, and then every part is exploded away from that base to show where it is in space and what it attaches to. And then if you were to put everything back together, you'll see the original model that we had on screen before.
Hi guys, I'm Clark. I take care of the design for the AEV. The reason why we chose our specific design against our other designs that we implemented was because it actually was more efficient using energy, and that was a big part of our AEV project. There's 2 fans in the back. They give a great push system to the AEV, and when it comes backwards, it also uses energy efficiently, even though not quite as much.
No, keep it. Keep it. No, you stopped it.
I'm Austin Hall, and I cover the team's programming. The program is the instructions that we give the AEV. It's kind of like pressing the buttons on a microwave. If you want it to cook for 3 minutes on popcorn setting, then you press the popcorn and then the 300. When we were programming the AEV, we had a lot of trial and error with each of the phases that we had. With the first phase, we came up to the first gate, and the problem that we had the most is either undershooting or majorly overshooting. So to fix that, we undershot with the AEV every single time with just a simple set of code that would tell it to go to a specific point. And then we had another snippet of code that would slightly adjust the AEV until it got into the gate position. And for the second part of it, we have to pick up the cart, which is at the very end of the track. And so for this, we have the AEV go to that same position as in the first part, but the reverse code, which fires the motors in reverse, go over a much longer time frame and at a lower power percentage. So that you just get the AEV gliding slowly to a stop and connecting with the cart. In the third phase, we have to take the cart back to the original gate, and this worked almost perfectly the first time. All we had to do was change the code, which was basically a mimic portion of that first section going around. And finally, with the last section of code moving from the gate back to the starting position with the cart, we copied basically the same snippet of code that we used for the first and third phases and altered it slightly to go a little bit farther but come to the same sort of stop. The AEV project was a good exercise in applied programming and various other engineering skills. I really enjoyed working with these guys, and it's a fun experience overall.
It was really interesting to see the entire design process of a product. We got to think of a product, create the product, and finally show off our product. And it was really awesome to do that for the first time in my life for an actual project. This class was really interesting, and I learned a lot of useful skills in it. Hopefully I'll use these later on in life.
In closing, I would like to say I had a lot of fun working on this project in engineering. Not only do you get to work with other students in a very fun environment, but you also learn a lot about what engineering has to offer if it's the right major for you. You study everything from mathematics to planning and development, design. You have to work in a certain time frame to complete a project, and you get to work with flying cars and dinosaurs. It's a lot of fun.
Overall, what was coolest about the project for me was going from a drawing or a few drawing ideas on a piece of paper to an actual vehicle that we can move around the track. And also just after testing and testing over and over again for weeks to finally have it work out the code perfectly was just a great feeling. So having all the hard work be worth it at the end and just work out was pretty sweet.
No, I mean, you can't. But like, put that company to pull. You can get somebody it's gonna feel weird, but go like this and you learn quickly.